Okay, I thought I'd do a short video on rearranging equations in physics, particularly for the energy topic since we've come across so many equations. So I'm going to start with the more simple equations. So these are the ones that have only 3 terms in them. So an example could be your power equals energy divided by time. Okay, so power equals energy divided by time, and let's say we have an example question that says my light bulb transfers 360 joules of energy and it has a power rating of 60 watts. How long was it on? Okay, so that's my question scenario. So step 1 then is to write what we have. Okay, so we've got power equals 60 watts. We've got energy equals 360 joules, and we don't know what time equals. Step 2 is to substitute what we know into the equation. Now, this wouldn't be the typical way I would choose to do it, but your exam board would give you marks for doing it this way. It would give you marks for doing it the other way as well, but your chances of going wrong, I'm not saying are high, but your chances of getting a mark doing it this way are almost 100%. So now we've got our equation above, and it's told us that 60 watts equals 360 joules divided by time. Okay. Step 3 then, we need to figure out a way of putting our equation so that we've got the time term on its own. Now, I like a formula triangle for these simple equations, okay? So in this scenario, energy goes on top and power and time go on the bottom, and we're solving for time, so we'd cover up time, and that would leave us with energy divided by power. So I could actually rearrange it now saying time equals 360 divided by 60, and then you calculate. Okay, so that's using a formula triangle. So time equals 360 divided by 60, which I think would be 6 seconds. Not trusting myself. Yeah, 6 seconds. Okay, so the bulb was on for 6 seconds. Okay, now if we want to use a more complex equation and rearrange that, that's really what I want to talk about today. So the probably commonly used most complex equation is the kinetic energy. So kinetic energy equals half times mass times velocity squared. Okay, now I personally like to do these rearrangements using the symbols rather than putting any numbers in. So I'm going to show you, got the wrong post-it there because I've got the elastic potential energy, but I've said before they're very similar. Okay, so that is your kinetic energy equation. So EK equals half times m times v squared. Now you could put this equation into a formula triangle, but you have to understand it mathematically in order to use the formula triangle, so I find it kind of pointless to try to do that. So instead of doing that, we do it mathematically. So first off, I'm going to rearrange this algebraic equation to solve for mass. Okay, so we've got a question that tells me that I've got something that's got a kinetic energy of this and it's going at this speed. What is its mass? Okay, so I've got kinetic energy of 40,000 joules and it's going at 15 meters per second. What is its mass? Okay, so first stage then is to deal with the numbers. Okay, so the numbers will help us do everything. So if I'm trying to isolate this term here, my aim is to get everything else over to the other side of the equation. So the first thing I'm going to do then, to get rid of the half, is I'm going to times both sides by 2. And that gives me 2 times kinetic energy equals mass times velocity squared. Okay, then I need to get this velocity squared term over to the other side. Because it's multiplied by the mass, I'm going to have to divide by velocity squared. So then you get 2 times EK divided by velocity squared equals mass. And that's your equation rearranged. Now I can put my numbers in. So we're going to have 2 times 40,000 divided by 15 squared equals mass. Okay, so 15 squared is 15 times itself, so that's 225. So we're going to have 80,000, because that's 2 times 40,000, so 80,000 divided by 225 equals our mass. So 80,000 divided by 225 equals 355.55555, so 356 kilograms, and that's to 3 significant figures. Okay, now the question didn't tell me what to give my answer in, so if in doubt you give your answers to 3 significant figures. You don't really get penalised for rounding too little, but you do get penalised for rounding too much, so 3 significant figures is kind of a safe bet. Now if I was going to work scientifically, I would say that actually it's only 2 significant figures given in the question. Okay.